So, recently I bought myself a battery. It's quite a big battery. It's 100 amp hour, and I bought it so that I can go camping and keep my fridge running. Picked it up off Amazon, pretty good price. But when it turned up, of course, the first thing I wanted to know is, what is the capacity? Is it actually 100 amp hour as it says on the ticket? So I've set up a test here to measure that, and I'll now talk you through it. From what I can find, there's no standard way of performing the tests. There are multiple standards for multiple standards bodies, which means you can assume that the manufacturers will choose to follow whichever standard suits them. Now, it might be legislated, but it may be that they just choose the standard that delivers the most favourable results for marketing. So Werchtay, who make my battery, don't seem to quote any standards at all, so I guess all bets are off with them. The specs on their website say 100 amp max discharge, 10 volt minimum voltage, but I don't consider either of those to be real world parameters. So all up, I've set up the test, I've conducted the test in a way that I consider to be a real world situation. So the way I'm going to conduct this test is to fully charge the battery, and then using a DC load, I'm going to apply a constant 1 amp discharge to that to the battery, and measure the amount of energy. So this is my battery. It's sitting in a carrier box, but I've disconnected all of the connections to the box as I don't want any unwanted load draining the battery during the test. The charger's on top, you can ignore that for the moment, and you can see it's a Werchtay battery rated at 100 amp hour, 12.8 volts, and just for interest, the temperature in my house is around 25 to 30 degrees Celsius. There's also some pretty funky connections going on. You can see I've used crocodile clips, which means that some of my connections will have quite high resistance, but that's okay. Those high resistance joints will not affect the test. At least up to a point that's true. I should add up to about 13 ohms total circuit resistance is okay if I'm discharging at 1 amp, but I'll make a separate video covering that in more detail. So this is the circuit. We have a programmable load that maintains a constant current draw from the battery. I'm showing 1 amp in this example, and the big letter I in a circle is a multimeter, which is reading current and streaming the readings to my PC. There's also a voltmeter connected across the battery terminals and streaming its readings to my PC. And the voltmeter also draws a few microamps from the battery. So technically this does introduce an error into the results, but honestly it's so small compared to the 1 amp that I just don't care about it. So here's the setup. Multimeters top and bottom, reading current and voltage, as you can see, and the clever device in the middle is my DC load. So it's off at the moment, it says off there. It's reading my battery voltage, and I've got it set to constant current mode. So it's a clever device. You can set it to constant voltage mode, constant resistance, constant power, and I'm using constant current. It's set to 11 milliamps at the moment. I'll flick it on here and you'll see 11 milliamps starting to flow. In fact, I saw a bit of noise there, like it was okay, so there we are. I can adjust that as well while it's running, which is nice. So this device is now placing a load, whatever load it needs to draw 21 milliamps. And this is what I was saying in another video when I say whatever load it needs to. It takes account of the circuit resistance, including all of the high resistance joints, and it only adds the load needed to achieve that 1 amp or whatever current I've chosen. So let's have a look at the software then. This is Python code, and ChatGPT wrote it for me. Thank you very much, ChatGPT. I had to be pretty prescriptive in order to get this outcome. You can see it's running on the left here, but I'll stop that now and start it from scratch. Well, let's just bring that into view. So, first thing it does is it detects which COM ports my DMMs are connected to. The DMMs are USB, I mentioned, but they appear as virtual COM ports in my PC. So the first thing the code does is it searches for available COM ports and then presents them to me, and it's asking me to choose which one is the voltage meter and which one is the current meter. So I'm going to do that now. 1, 2. It does a quick communications check with the two devices, and then it starts logging. Let's wind that out. So every second you can see voltage measurement, current measurement. I've also thrown in there amp hours and watt hours, which later proved to be completely useless. You might have noticed when you saw the Python code that that was reading close to 0 current. It's because this was turned off. And just to prove it, let's set this to 0.5 amp. That will do nicely. Cool. Oh, and there we go. So 0.5 amp flowing. So as you can see, it transitions from near 0 load to 0.5 amp. These readings get logged every second and saved to a file. And I just want to clarify something I said when we were looking at the code. I talked about the amp hours and the watt hours are useless. They're both useless because they both need the time to be contiguous from the start of the test all the way through to the end of the test. And of course it wasn't, because I unplugged my laptop during that time. Logging ceased for other reasons as well. So let's just to clear that up. So onto the results. I've now gathered data for 1 amp and 10 amp discharge, as I mentioned. One of the key things to decide is at what point do you stop counting the 100 amps, right? I.e., when do you stop the test? In other graphs I've seen, the battery is discharged to 10 volt or even lower, but I don't want to take it down that low. I figured that if I bought a 12 volt battery, I kind of want it to be around 12 volt or higher. And 10 volt just doesn't seem, it just seems too low. My fridge, for example, just won't run down at 10 volts. Anyway, as it happened, the battery only dropped to 12.5 volts, so it wasn't an issue. It may be with hindsight that the manufacturers stopped the test when the BMS cuts off. So here's the 1 amp graph. Naturally, it took 100 amps to discharge. That's just under 4 days. By the time it had delivered 100 amp hours, the voltage had dropped to 12.5 volts, and honestly, that's the level I'm happy with. I've also marked where the voltage drops to 12.8 volts, because if you remember, the batteries are labelled 12.8, as they all seem to be. Now, I couldn't find a good explanation of what this figure represents. Initially, I thought it meant the battery will deliver 100 amp hours by the time it gets to 12.8, but in the end, I haven't interpreted it that way, so it's just a value you can use to compare the two graphs. One thing to add, if you're wondering about the blip at the end of the test, that's where I unplugged my PC. It stopped logging data, but the battery's still being discharged and it won't affect the results. And this is the 10 amp discharge test. It took 10 hours to deliver 100 amp hours. Pretty obvious. And at the end, the battery voltage had dropped to 12.39, which is a bit lower than the 1 amp test. largely this is due to the high internal losses in the battery, which means more heating, more wasted energy, and ultimately you can't get quite as much energy from the battery at higher current. It delivered 85 amp hours by that 12.8 volt mark compared to 89.5 at the 1 amp discharge. So again, it demonstrates I get a bit less energy from the battery at higher current. So look, in summary, I'm comfortable. I'm comfortable that my battery does what it says on the tin. 10 amp is a pretty reasonable current, and it still had a bit left after delivering 100 amp hour. My fridge only draws about 3 amp, so I should get slightly more than 100 amp hour. My fridge will last a while. Look, thanks for watching. I hope you enjoyed it.